This chapter will cover the scientific method. So the scientific method is a way to gain knowledge about behavior and mental processes. And it really extends our everyday ways of knowing. It's not one particular technique or tool, it's this general approach to how we learn new information. So the general structure of this chapter is really to compare what we do in the scientific method to our everyday ways of gaining knowledge, or non-scientific approaches. So we'll talk about the general approach, the attitude, observations, and so on. Okay, so in terms of the general approach or attitude, we talked last chapter about the scientific method involving being kind of skeptical in trying to critically evaluate claims before we accept them. In contrast, non-scientific approaches tends to be intuitive. What seems to be right or reasonable, we accept. And so when we just kind of accept what people tells us, we miss that perceptions might be distorted by our cognitive biases, by what we expect to be true or what we want to be true. So when we do a scientific approach, we really try to be critical, skeptical, and empirical, meaning we collect our own data. Observation. So in a non-scientific way, we do observe other people casually, but we don't do it in a really controlled or specific way. We let personal bias potentially influence our observations, and so it's not a very accurate way of assessing people, observing people. When we use the scientific method, we try to be very systematic and controlled in the way we do observations. So control really has to do with manipulating the factors that could influence the phenomenon we're observing. And so in an experiment in particular, we formally manipulate these factors. So we might change one or more variable and observe the effects of manipulation on behavior. So if we're interested in cheating behavior, we're gonna control everything else, put people in the same situation. In one, they know they're being watched, and in one, they don't know they're being watched. And we assess, do they cheat or not? And the one variable we're interested in is cheating. So do they take advantage of that? And so this kind of idea of scientific observation has many roots, but I love this quote because it really shows kind of what we try to do in an experiment. If you want to understand something, try to change it. So in an experiment, we have the best level of control. And so we try to investigate one variable at a time. So we isolate one thing that we are studying and try to investigate it. So the independent variable is the factor that an experimenter is manipulating to determine its effects on the behavior. So the independent variable is what is changing. It's what we think the cause is. The dependent variable is the measured, normally a behavior that we expect to change. So the dependent variable is the outcome that you're interested in. I'm going to tell you that this concept of an independent and dependent variable is very important. We're going to keep coming back to it over and over again. So the independent variable is what we manipulate, and it's what we think of as the cause. The dependent variable depends on the independent variable, and it is the outcome. It's what we're trying to change. So at its simplest, an independent variable has two levels, present or absent, okay, or maybe treatment or control. If we want to know, does Advil relieve headaches, we're going to have one group that gets Advil, which would be the treatment group, and one group that doesn't get Advil. That would be the control group. So those are our independent variable is Advil. We've got two levels, gets it and doesn't. And then the outcome is how much headache do people have? Okay, so generally our control group measures behavior kind of before and after without any treatment. And then our treatment group, or experimental group, it's sometimes called, actually gets whatever the independent variable is. We need a control group though, it's very important, because maybe people with worse headaches are more likely to take a different kind of drug. Like we don't know how things would change on their own if we didn't have a control group. Okay, so I'm going to have several of these test yourselves throughout this lecture and the rest of the lectures. And so I really encourage you to pause the video here, read the scenario, answer it on your own before playing, and then I will give you the answers on the next slide. So pause here and read it. Generally, the scenario is Pennebaker and Francis studied adjustment in college, and they had students write about their emotions associated with being in college, or they wrote about superficial events that took place during their day. Then the researchers obtained information about the participants' GPA and the frequency of visiting the student health center. So I want you to identify what's the independent variable, what are the levels or versions of the independent variable, and what is the dependent variable. So go ahead and pause the video and answer these questions. Okay, so in terms of the independent variable, remember the independent variable is what they manipulated, and they manipulated the type of writing. Okay, they asked all the students to write, but they were asked to have different types of writing. The levels of the independent variable, the versions of writing, were emotional or superficial. Okay, so those were the two different versions of the experiment. Everyone did some type of writing. Some got emotional writing, some got superficial. And then the outcome that they were interested in, the dependent variable, was the GPA and the number of health center visits. And what they found was that students who wrote about their emotions actually had higher GPAs and fewer health center visits compared to students who wrote about superficial events. So here is another one. In a study looking at factors that influence people's willingness to help others, a researcher mimicked or copied the behavior of participants, how they were sitting, their posture, etc. Or they didn't mimic the participants' behavior. The researcher then dropped pens and observed whether participants helped them pick up pens. So again, I want you to identify what is the independent variable, what did they manipulate or change, what are the levels of the independent variables, what are the different versions of the experiment, and then what is the dependent variable. So go ahead and pause and jot down your answers. Okay, so for this one, the independent variable, the thing that they thought caused a change was the mimicry or copying of the participants. The levels were either present or absent, right? So the present was the treatment condition where the researchers copied them, and absent was the control condition. And then the dependent variable was whether participants helped pick up pens. And what they found was that all of the participants whose behavior was mimicked helped, whereas only 33% of the non-mimicked participants helped. So it seems that we're more inclined to help people who are behaving like us. Okay, so next we're going to move on to concepts, and I want you to just take a second to think about how do you define happiness. See if you can jot down some kind of definition. You might find that you have kind of a hard time putting it into words, even though we really know what happiness means, or we have experienced it, it's hard to actually put into words. And so happiness is a concept. It is a thing or event or relationship among things, but it's kind of vague. So when we take a non-scientific approach to happiness, it tends to be ambiguous, right? So maybe you said happiness is smiling or being with people you love. We use words that even when we don't have a clear meaning for them. When we take a scientific approach to things, we really need to have a clear definition about what the thing is. Because happiness might mean two different things to two different people, right? Being with my family might make me very happy, but being with somebody else's family might not make them happy. So when we use a scientific approach, we need to have very clear and specific definitions. The construct is what we call these concepts. Okay, so a construct is a concept or idea in psychological theories to explain behavior or mental processes. So this is kind of crucial to science, psychological and social sciences. So these can be all kinds of things: aggression, depression, emotion, intelligence, memory, personality, stress, well-being. All of these things we've experienced, we've seen, we've witnessed. They're the kinds of things that social scientists study, but how do you assess them? And that's where we get to the operational definition. So the operational definition is how we measure a construct in a specific way. Okay, so this is some kind of observable procedure used to measure the construct. This is what we've agreed for the purposes of our study we're going to assess. So this is just kind of another way to define it. A construct is something that we think it's real, okay? But it's intangible. It can't be touched or seen. We have to try to measure it though, because these are what most social science studies are. So another example is sexual jealousy. We think it exists, can't be touched or physically seen, but somebody might have emotionally felt it. So then we have to create an operational definition. And so we have to figure out, how are we going to measure it? So if we're measuring sexual jealousy, this might be, maybe we assess how people respond to a hypothetical situation. We might measure heart rate or facial expressions, ask people about their emotions, things like that. But the thing to remember is different operational definitions might lead us to different results. So the general idea is that a construct is a general phenomenon. The operational definition is how we measure that construct. Okay, so next I want you to go through, take a second, look at this list, and identify which are the constructs. Go ahead and pause the video. All right, so we have several constructs on this list. So anxiety, we probably all felt it, but we have no clear way to define it. Milk, you can measure objectively how much milk someone has. You can measure a cup of milk. Faith, if we look at something like religious faith, we may have felt it, we may have seen it, but we can't directly measure it. In contrast, money, we can count, right? We can count how much money someone has. Intelligence is another one we talk about a lot. Definitely a construct. Sadness, you can't directly measure sadness. Lying is kind of a tricky one, but if you set up a world in which you kind of know the truth, then you can count how many times someone lies. So lying might be the operational definition of dishonesty. Okay, so next I want you to come up with operational definitions of each of these. Okay, so go ahead and pause it and figure out, if you were doing a study on these constructs, how would you assess them? Okay, so there are no right answers, but these are some examples. If you were studying anxiety, you could look at someone's score on an anxiety scale. You could also measure heart rate or things like that. If you were measuring faith, you might ask how many times a person prays a week. Intelligence might be measured through the score on an IQ test. Sadness might be something like the number of times a person cries in a week. So again, there's lots of different operational definitions for each one of these. Just how you assess it is what the operational definition is. Okay, so here's another scenario. I want you to identify the construct and the operational definition. Researchers measured heart rate and blood hormone levels after administering drug A or drug B to determine the effects of each drug on anxiety. And so the answer, the construct is anxiety, and the way they've measured anxiety is by measuring heart rate and blood hormone levels. And just as a bonus, if you've identified the independent and dependent variables, the independent variable is the drug, the levels are A or B, and then the dependent variable is the anxiety. One final one, I want you to see if you can identify, and I go ahead and pause it after, but I've got a constructs listed and some various operational definitions. So see if you can identify which operational definition goes with which construct. And here are the answers for that. So you can pause it so you can score yourself. All right, so The advantages of using operational definitions is we can really clearly define constructs and it allows very clear communication. However, the disadvantages are that there are potentially a limitless number of operational definitions of any construct. And some operational definitions might be meaningless. So if we don't already have an operational definition, we don't have a clear measure of whatever we're studying, we can just make one up. But that doesn't necessarily mean it's a good one. Okay, so measuring head circumference used to be used as a way to measure intelligence. It's not actually an accurate way of measuring intelligence. Okay. Next, we'll talk about hypotheses. And so an important part of making good observations is making predictions. So a hypothesis is a tentative explanation for something. Non-scientific hypotheses are untestable. So very importantly, scientific hypotheses need to be testable. They need to be concepts that are clearly defined and measured. So some common things that we see in non-scientific or untestable hypotheses are constructs that are not adequately defined or measured. So saying someone is mentally disturbed, what does that actually mean? Hypotheses that are circular. So an event itself is used as an explanation for the event. Shy kids have bad peer relationships because they're shy and anxious. It doesn't tell us anything. It's just using the cause as the explanation. Also appeals to ideas or forces not recognized by science. The person is doing that because they're controlled by the devil. Whether or not it's true, we can't actually assess that. So some things that make a good hypothesis, one of the most important things is that it needs to be directional and it needs to explain how things are related. Okay, so you can't just say that you expect things to be related. You need to explain the direction. So here's some examples of some good hypotheses. So it's hypothesized that individuals who receive math tutoring will have higher IQ scores than individuals who do not receive tutoring. Okay, so it's describing an experiment. Some get tutoring, some don't. The outcome is the IQ. And we've got a clear direction, right? Those who get tutoring will have a higher IQ score. The next one, it's expected that children who drink sugary drinks will do worse on the test than children who drink water. Again, seems to be an experiment. Some get sugary drinks, some get water. The outcome is the test score. And we know that they think the ones who drink the drinks, sugary drinks, will do worse. So we know the direction. It's expected that higher math anxiety will lead to lower 30-15 grades. So this is a correlation. No one's manipulating anything, but we have the direction, right? More math anxiety leads to lower grades. And then finally, it's expected that higher optimism will be related to lower depression. Again, an experiment, a correlation, but we see the direction. More optimism, lower depression. This one, I want you to test yourself and see if you can identify what's wrong with this hypothesis. So go ahead and pause it now. All right, so for this one, we're going to test to see if math tutoring improves IQ. There's no direction. It just says what they're going to do. Sugary drinks will affect test scores. This doesn't explain the direction. It doesn't tell us how they expect the independent variable to affect the dependent variable. The third one is a question, right? Does math anxiety lead to lower 30-15 grades? So it does state a relationship, but it's stated as a question, and a hypothesis always needs to be stated as a prediction. And then finally, optimism and depression will be related. That's great, but it doesn't tell us what direction. Okay, so next, another big difference is in reporting. So non-scientific reporting tends to be kind of a biased or subjective retelling of a story or event, often includes personal impressions. When we do scientific reporting, we really try to avoid making inferences. So we try to be unbiased and objective. So if we see two kids pushing each other, could be bullying, they could be just roughhousing, we try not to jump to conclusions and instead we report exactly what we see. We try to use separate observations, separate our observations from our inferences. So here's what I saw, here's what might happen. We also look at inter-observer agreement. So we have two different people watch the same thing and look at, do they record the same behavior? Do they both interpret it as bullying? Okay, another difference between scientific and non-scientific approaches are the instruments. So non-scientific instruments tend to be inaccurate and imprecise. So they're not very good. They're not very detailed at assessing what they're assessing. Scientific instruments tend to be accurate and precise. So accuracy is the difference between kind of what an instrument says is true and what we know is true. So it actually gets at the truth. And precision has to do with how small of a unit something measures. Okay. In terms of the measurements, non-scientific approaches tend to measure concepts that are inaccurate or inconsistent, where scientific measurements really try to get at validity and reliability. So validity has to do with the truthfulness of a measure. Does it measure what it claims to measure? So if we operationally define aggression as how long someone squeezes a stress ball, is that actually a valid measure of aggression? If it is valid, do similar measures of aggression get the same responses? These are questions that we test. Reliability has to do with consistency, either over time or over observer. So, if you take the same IQ test repeatedly, you should get generally the same score. If you don't, it's not a very reliable measure. And inter-rater reliability is when two people are observing the same behavior. Do they write down the same rating? Okay. We also look at kind of physical measurements. And so one of the challenges with social science is we don't have a lot of physical measurements. So physical measurements are an agreed upon standard. Length, weight, time, blood pressure. These are all kind of very well standardized things. The psychological constructs that we measure tend to have no agreed upon standard or no clear instrument. And so what happens is researchers tend to develop measures to assess psychological constructs. And sometimes we have multiple. So for intelligence, there are the WISC tests, there are Stanford-Binet tests, SATs, GREs, things like that. Lots of different measurements, which can create problems. Okay, so moving on, we have four main goals of the scientific method: description, prediction, explanation, and application. So when we talk about description, what we are trying to do is define, classify, catalog, or categorize events and relationships. Describe the events or the relationships between variables. Most of what we'll talk about in this class is quantitative. So findings are products of statistical analyses, as opposed to qualitative studies, which look at verbal summaries and tend to use few statistics. They tend to be based on interviews and observations. These are much more common in like sociology and anthropology. Another big goal is prediction. Okay, so correlations and relationships allow us to kind of, a variable, just as kind of a basic starting point, a variable is a dimension on which people differ or vary. And correlations look at two measures within the same person and whether they vary or go together. So something like, do GRE scores predict success in graduate school? Okay, and so correlations are really important for helping with prediction. But it's important to remember that correlations do not imply causation. So for example, we know there's a correlation between attendance and grades in a class, but we don't know that attendance causes grades. Maybe there's a health factor that influences attendance and also makes students have worse grades. But so it's important to remember that prediction doesn't always mean we know something for sure. So the fact that there's a correlation there doesn't mean we know something for sure. There could be other things happening. Okay, so I want you to kind of start thinking like a researcher and start thinking about some of this correlational evidence. So here's one example. Married women are found to suffer from depression more than men. However, when couples have greater marital compatibility, the married women have less risk of depression. So pause and take a second to jot down some ideas about why this might happen. And here are some potential thoughts. So maybe when couples have a more compatible relationship, it causes less depression. Another possibility, though, is that when women are less depressed, it makes them easier to get along with and makes their relationships more compatible. And then finally, it could be something else altogether. So it could be that maybe the amount of emotional support in their relationship predicts both their compatibility and their depression. So when we find a correlation, there are many possible explanations. Here's another one for you to think about. This is heart patients. Pet owners are more likely to be still living 1 year after they're discharged from a heart unit than people who don't own a pet. So why might this be happening? So again, couple of conclusions. So one is that pets cause good health, right? If you have a pet, then you might be more likely to walk and exercise. However, it's also possible that people who were healthier to begin with were more likely to get pets. Or finally, there could be some other factor altogether. People with supportive families might be more likely to get pets and be healthier. So anytime we have a correlation, there are many possible explanations. In contrast, when we're controlling experiments, this can really help us identify and narrow down potential causes. So in a controlled experiment, we have an independent and dependent variable, and we manipulate one factor at a time to determine their effect, and then we measure the outcomes. This is in contrast to an experimental study where generally researchers are not actually manipulating anything. In an experimental study, they're just measuring them. In a correlational study, they're just measuring them. In an experiment, we manipulate the factor of interest, the independent variable, and we measure the dependent variable. Okay, so the goal of experiments is to establish a causal inference. Can we say definitively that X caused Y? And so there are three conditions that allow the establishment of a causal inference. Okay, so the first is the covariation of events. So this is basically that there's a correlation or things change together. So if we take the example of taking does Advil make a headache better? Maybe there's a correlation there. The more Advil you take, the less of a headache you have. If you don't take Advil, your headache persists. The next important factor is the time order relationship. Does the cause happen before the effect? So if you do you take the Advil before the headache goes away? If the headache goes away before you take the Advil, then obviously the Advil didn't do it. And then finally, have you eliminated possible alternative causes? Maybe it was the glass of water that you drank when you took the Advil. And so we need to have a controlled experiment where people have water versus don't have water to see if that could be a cause. So often we tend to conclude causation after only the first criteria has been met, that there's a correlation. And that is a significant mistake. So these three are very important to remember. This is what we need for causal inference. Okay. This is just an example of kind of a spurious correlation. You can look at the housing price index and babies named Ava, and you can see that they are both increasing pretty dramatically and peaked in 2008, then decline in 2009. We wouldn't say that babies named Ava caused the housing bubble, but there is a correlation there. Okay, so one of the hardest things to get rid of in research is other possible explanations. So this is called confounding. When two independent variables vary together or change together. This means that we cannot determine which independent variable caused the effect on the dependent variable. So in order for us to truly have causal inference, the experiment must be free of confounding variables. So for example, if we're doing a study on after-school programs and we have some kids who go to an after-school program where they play with other kids and they get tutoring, and other kids who go straight home, and we find that the after-school program improves grades, we might be excited, but we might say, wait, because the kids in the after-school program are getting tutoring, but they're also getting lots of other interaction. And so we don't know if it's actually the tutoring that improves their grades or the other interactions that might also improve their grades. So we need to do more research because we have that confounding variable. Okay, so here's another example. A psychologist develops a new therapy for helping students cope with stress. One group of students receives the new treatment and a second group is placed on a waiting list to receive treatment during the next term. So they're the control. To make sure students in the control group maintain their interest in the research project, an assistant calls them every week to check in. And then the psychologist measures the coping of students in the treatment and the control group. So I want you to identify the independent variables and the levels, the dependent variable, the confounding variable and why it's a problem, and then think about how you would address this. So go ahead and pause and write down your responses. Okay, so in this study, the independent variable is the therapy and the levels are yes and no, right? Either they get the therapy or they're in the control. It could be experimental or control or treatment or control. You just need to describe the different versions. So again, when you're doing these, the independent variable is the general term for what's being manipulated, and the levels are what the different things that people get. The dependent variable is their coping. That's the outcome. The confounding variable, though, is the weekly phone call to check in, right? That's almost a kind of therapy. And so we're not sure whether it was actually the therapy that helped, or maybe they didn't find, or whether the therapy actually didn't work, or maybe it was just that these weekly phone calls were enough. And so how would you address this? Well, really, ideally, we'd have a third group that had no phone calls. Maybe they had a letter check-in or on an app or something like that. And that would really tell us, was it the therapy itself? Was it the phone calls? Maybe just talking to someone helps. Okay, we also want to be able to generalize. So we want to generalize our findings. So we're not just interested in the people who participated in our experiment. Generally, when we do a study, we want to be able to generalize to different people, different settings. If we study aggression in a lab, we're probably not just interested in how aggressive people are in the lab. We want to know how aggressive they are outside of the lab too. Different conditions. So does frustration with a lab task, or if frustration with a lab task leads to aggression, does frustration with a boss also lead to aggression? So generalizing beyond the context. We also worry about application. So we study social sciences to improve people's lives. So we want to know how we can apply the knowledge we've gained. We'll focus most in this class on basic research, where the primary goal is to understand the behavior and mental process. So this tends to be more in a laboratory setting. But there's also a whole other branch of research that focuses on applied research, where the explicit goal is to improve people's lives. Often this is taking that basic research and applying it to new information. Okay, so lastly, we're going to just briefly talk about theories, which are proposed explanations for how things work. So these are the broad frameworks that really determine what we're studying. And these help us to define our concepts, help us predict how the relationships might work, and explain the occurrence of events. So I know this was kind of a long lecture, but this material is really foundational. So I encourage you to go back, if you haven't already, do the test yourself, because this stuff is going to be really important for the rest of the semester.